Hello and welcome, my dear students, to my channel Mathematics Made Easy. This is Ms. Ruchika welcoming all my grade 9 elite students to the exam coverage material for the final exam for term 1. So we are covering today part 1 of end of term examination series exclusively for all my grade 9 elite students. It's an important and a must watch video, so watch it till the end so that you can take maximum benefit from the questions that we will be covering today. A humble request, a kind reminder to like, share and subscribe to the channel if you haven't done still yet. And now let's get started with today's session. Our primary goal in the session today would be to review the end of term questions and the important questions that will help you for your final exam. We will be covering from the end of term exam coverage series questions 1 to 7 in today's session. So let's get started. So let's first solve the questions from module 10 exponents and powers, and our learning objective here is find the power of a product. These are question 9 to 12 on page 575 of your math book. So the first question has three powers. You can see 2, 2 and 2. So it is like 2 multiplied with 2 multiplied with 2. The powers will get multiplied. So 2 multiplied with 2 multiplied with 2 will give you 2 to the power 8, which is same as 256 on multiplication. So that's the simplification of question 9. Let's move to question 10. Here also you have three powers. So you are going to multiply the three powers. 2 with 2 with 4. So the power is going to be 3 to the power 16, a big number. Look at this one here. You have 4rt square whole to the power 3 whole to the power 2. So let me write it in a different way. 4r square t whole to the power 3 and whole to the power 2. So there are two powers, 3 and 2, they will get multiplied. So this can be written as 4r square t whole to the power 6. Remember, when there are two powers and they are raised to each other, we are using the law a to the power m whole to the power n. The power gets multiplied, m multiplied with n. So now we can distribute the power to each of the terms here. So it becomes 4 to the power 6, r to the power 12, t to the power 6. This is your final answer. Let's move on to the next question. Here you have 3 to the power 3 multiplied with 2. So this will become 6. So this is same as minus 2y square whole to the power 6. Now you distribute the power to 2, to x and to y. So this is going to be minus 2 whole to the power 6, x to the power 6, y to the power 2 to the power 6. So this is going to be, this is like minus 2 but even power, so it will be plus, and 2 is multiplied with itself 6 times. So this is going to give you 64 x to the power 6, y to the power 12. So this is going to be the answer here. So now you have all the answers. The answer for this one is this, the answer for this one is this, the answer for this part is this, and the answer here is this. So question number 9 to 12 are solved in this way. Next we have simplifying each expression assuming that no denominators equal 0. So here the learning objective is simplify expressions containing 0 and negative exponents. So remember, I'm going to revise the rule for you. If it is a to the power minus m, it means same as 1 over a to the power m. So you can convert a negative exponent, this is a negative exponent, to a positive exponent using this rule. Okay, that's what we are going to do in these questions very shortly. And also any base raised to the power 0 is always 1. So this is 0 exponent. Wherever you see to the power 0, you will always keep it as 1. So for example, if you see carefully, t to the power 0 is given. So this will be 1. That's a 0 exponent. And you see negative powers also here. So this is same as f to the power minus 5, g to the power 4 over h to the power minus 2. Now I can write these negative exponents in terms of positive exponents. So what I will do, I will bring this f to the power minus 5 down. So it will become f to the power plus 5 using this law of exponent, using negative exponents. G to the power 4 will be as it is already positive, we need not change it. H to the power minus 2 is negative, so we'll bring it up, it will become h square. So this is the first solution. Let's do a little bit more here. Again, you see for this question, negative exponent y to the power minus 9 and y to the power minus 11. So we are going to convert into positive exponent. Then we have x to the power 6 and x. So we will apply subtraction law. So a to the power m divided by a to the power n is a to the power m minus n. So x to the power 6 divided by x to the power 1 would become x to the power 6 minus 1, which is x to the power 5. That's what we'll do here. And 15 and 5 will be divided to give you 3. So this is 3 x to the power 5. Now y to the power, this is minus 9 plus 11. Minus 9 plus 11. So the power will become y square. Okay. So because it was division, the power gets the power goes up, so it becomes minus 9 plus 11, and that gives you a y square. So this is the answer. Let's solve this one. Here it is negative sign, so negative 3, 15 divided by 5. T to the power 0, as I already told you, became 1. U to the power minus 1 minus 3 would give you minus 3 u to the power minus 4. We don't like negative exponents, so we are going to make it positive by bringing it down. So this is the answer. Next we have question number 8. Here the power 3 is outside, it is going to distribute inside. Similarly, the power which is outside 2 is going to distribute inside. So this is going to give you z to the power 6 w to the power minus 3 divided by z to the power 6 w to the power 4. So when you simplify, z to the power 6, z to the power 6 cancels, and this is going to give you w to the power minus 3 minus 4, which is w to the power minus 7, or 1 over w to the power 7. Okay. Now let's solve this question. Here you have minus 10 and minus 14. So minus minus becomes plus. Simplify, it becomes 5 by 7. M to the power minus 1 plus 7 would give you m to the power 6. Y to the power 3 and r to the power 5. So what did we do? The power we made minus of, let me write here, minus of minus 7. So it became minus 1 plus 7, which is 6. Next power was minus 1. Next power was 0 plus 3. So that gave you 3. And next power was 1 minus of minus 4, which gave you 5. So I'm talking about the terms in this expression that we have taken to get our answer. Next we do question 10. In a similar way, you simplify and the answer would come out to be 3y square over x cube. In this one you also simplify and the answer will come out to be 1 by 4 r4p square over m cube d4. So this is how you do question 5 to 11 using negative exponent and knowledge of zero exponent. Let's move on to nth roots and rational exponents. Here we are going to use the method of prime factorization for solving the question. So we'll do prime factorization of the numbers that you see here: 729, the base 256, 125 and 49. Now these are simple. This is 7 square, this is 5 cube, but for the bigger numbers 729 and 256 we need to do the prime factorization. So let's do it. 729, when you start dividing it by 3, it's an odd number. 243, again by 3, 81, again by 3, 27, again by 3, 9, again by 3, 3, 3 and 1. So that means 729 is 3 to the power how many times? 1, 2, 3, 4, 5, 6. So 3 to the power 6. This is what you get. In a similar way, 256 will come out to be 2 to the power. Okay, you can try the prime factorization of that also. So now I'm going to convert this solution. So this can be written as 3 to the power 6 whole to the power 5 by 6. Now I can cancel 6 with 6. This is same as like multiplying the powers. So I will cancel 6 with 6 and the answer is 3 to the power 5 or 240 simplified form. Let's do this one. This is 5 cube to the power 4 by 3. In a similar way, 5 3 multiplied, the power is multiplied, so 4 by 3. 3 and 3 gets cancelled, so 5 to the power 4, which is going to be 625 is your answer. Let's do this one. This is 7 square whole to the power 5 by 2. Again, it can be written as 2 multiplied with 5 by 2. Cancel 2 with 2, so this is 7 to the power 5, which is a big number, 16807. Now we are just left with 22 question. I'm going to put the answer here since I have less space there. So you do the prime factorization of 256 and it comes out to be 2 to the power 8. So this can be written as 3 by 8. Again we apply the same law, the power gets multiplied. So 8 multiplied with 3 by 8, power gets cancelled and this is left with 2 to the power 3, which is 8. So that's the answer. So this is how you solve the nth roots and rational exponents. Let's solve the following exponential equations by using the power property of equality, and for doing so we have to again do the prime factorization of these big numbers that you see here. So let's first do the prime factorization of 243, and when you're doing the prime factorization you have to keep looking at the base on the other side. The base is here 6, so you are going to start dividing by 3. Here the base is 6, so you will start dividing by 6. Here the base is 2, so you will start dividing by 2. Here the base is 4, so you will write it as a power of 4. Here the base is 4, so you will write 1024 as a power of 4. Here the base is 3, so you'll write 6561 as a power of 3. That's the hint for you. So 243, let's start dividing with 3. When we do that, we get 81. Again we do that. Division, we get 27, again with 3, 9, again with 3, 3 and 1. So how many powers? 1, 2, 3, 4, 5. 5 times. So 243 can be written as 3 to the power 5. That is what I'm going to replace here. 3 to the power 5 before I use the power of inequality. So 3 to the power x minus 3 is 3 to the power 5. Now the power of equality says if the base is same and the value is equal, the power is also equal. So I can say x minus 3 is equal to 5, or x is equal to 3 plus 5, which is 8. So the answer here for the value of x is 8. Similarly, let's do another one. We'll try question 8, 1024, and I told you we have to write it as a power of 4. So when I'm dividing 1024, I'm starting to divide with 4. It gives me 256. Again, I do with 4. It gives me 64. Again with 4. It gives me 16. Again with 4. It gives me 4 and 1. So y to the 4 to the power 5 is what is this value. So again, I can solve in a similar way using power property of equality, that 4 to the power x minus 1 is equal to 4 to the power 5. That means the powers are going to be equal. So x minus 1 is equal to 5, or x is 6. So this is how we solve the question. Okay, now I would want you to try similarly the remaining questions. Do the prime factorization of 1296 to get your answer. And this one is easy, so let's do it. Answer 10. 4 to the power 2x plus 1 is 4 to the power 5. So 2x plus 1 is equal to 5. So 2x is 4, or x is 2. Okay, so we've got this answer as well. Similarly, try this one. The answer for the value of this question would come out to be x equal to 5. I'm giving you the answer before. The answer for this one is already done. Try these two questions, 11 and 12 yourself. And let me know in the comment section what answer you got. Let's now review how to add polynomials. This is a very easy topic. If it is subtraction, the terms will subtract and you collect the like terms. So the rule is collect like terms together. And if there is any negative sign, then you change the sign of the term that is getting subtracted. So when you do that, the answer of 27 will come out to be 3c cube minus 3c plus this. The answer of 28 would come out to be 2z square plus z minus 11. The answer of this one would come out to be minus 2x minus 5y plus 1. The answer of this one would be minus 2b square minus 2a plus 9. The answer of 31 would be minus x square y minus 3x square plus 4y. The answer of 32 would be minus 2xy plus 7 square minus this. The answer of 33 would be minus 6b square plus 2nb minus n, and the answer of 34 would be minus rt rxt minus 8r square x plus 3x square minus 6rx square. So check your answers and let me know are you getting the correct answers or not. Let's now multiply binomials by applying the pattern formed by squares of sums or differences. So here we have used the algebraic identity. I'm going to write the identity for you. A plus b whole square is equal to a square plus 2ab plus b square. So here you see a plus 10, same term. So this is same as a plus 10 whole square. So its expansion would be a square plus 20a plus 100. So this is how you find the product. Similarly here also the answer would be b square minus 12b plus 36. We are using this identity and the expansion on the right side. This one would be h square plus 14h plus 49. This one would be x square plus 12x plus 36. This one would be 64 minus 16m plus m square. This one would be 81 minus 36y plus 4y square. Same way, we are just using this expression, this identity, to give the answers. Here it would be 4b square plus 12b plus 9. Here it would be 25t square minus 20t plus 4. Here it would be 64 h square minus 64 hn plus 16 n square, and here lastly it would be 16 m square minus 40 mn plus 25 n square. So this is how each of them would be multiplied using the identity of algebra. That brings us to the end of today's session. That was part 1 of end of term exam coverage specifically for my grade 9 elite students. And if you have not subscribed to the channel, I would give you a humble reminder to please subscribe so that you don't miss part 2 of end of term exam coverage, which is coming out soon in a few days for all of you. Stay glued to my channel, share this video with your friends who will find it useful for their final exam. Until then, this is Ms. Ruchika signing off from today's session. See you in my next video. Bye students.